1954, Mercedes-Benz returned to Grand Prix racing with a purpose-built weapon, the M196 Straight-8. It did more than satisfy a rule change. It redrew the blueprint for a modern racing power unit. Mechanical direct fuel injection, desmodromic valve control, a radical right-hand cant, and low-drag bodywork were designed as one coherent system. On track, the effect felt deadly, a surgical dominance that won early and often. And, by the end of 1955, the word carried a darker echo history would never forget. Blank slate rules. Surgical return. Formula One's 1954 regulations offered a rare, clean sheet, either 750 cubic centimeters with a supercharger or 2.5 liters naturally aspirated. Stuttgart chose the latter and rebuilt a factory team to prosecute the rule set with aerospace discipline. Rudolf Uhlenhaut's department refused to treat engine, chassis, and coachwork as separable topics. The program's first public face, the W196 Streamliner rolled out at Reims, explained the philosophy in an instant. Low frontal area, long gearing, and peerless straight-line stability made sense on a power circuit. An open-wheel monoposto followed for places where sight lines and quick rotation mattered more than drag. Both shapes sprang from the same starting point. Place the engine so low and so far out of the wind that the air's job becomes easy. That required a space frame that could cradle a canted inline 8, a transaxle that preserved the rev band, and suspension layouts that kept tires planted while the body slipped through the air. Instead of producing a fast engine and searching for a car to match, Mercedes produced a single machine whose parts did not compete with each other for space, heat, or purpose. Mercedes's preparation mirrored its philosophy. Test sessions were scheduled to answer narrow questions. How much bonnet height could be removed before cooling delta T suffered? Which gear set kept the engine on its best mean effective pressure? Which wheelbase allowed drivers to breathe the car through fast changes of direction? Uhlenhaut's habit of driving development cars himself kept feedback brutally honest. If a change did not make the stopwatch and the steering wheel agree, it was discarded. Inside the beast. Architecture with a purpose. The M196R displaced 2,496 cubic centimeters with a bore and stroke of 76.0 by 68.8 millimeters. A Hearth roller-bearing crankshaft carried its power takeoff at the middle, dividing torsional load across two shorter spans and calming the long 8 at speed. Crossflow heads kept intake and exhaust apart. Twin-plug ignition shortened flame travel. A dry sump system scavenged oil to a separate tank so the whole unit could sit exceptionally low. Engineers canted the block roughly 53 degrees to the right. The installation lowered the bonnet line to an almost unbelievable degree on the Streamliner, tucked the exhaust neatly down one flank, and left the opposite side cool and short for intake plumbing. Packaging gains multiplied aerodynamic gains. Less frontal area meant less drag. Less drag meant fewer cooling compromises. Fewer compromises meant more repeatable pace across a full race. On debut, the engine produced about 256 to 260 brake horsepower. By late 1955, careful breathing, manifold tuning, and calibration lifted the figure toward 290 brake horsepower, near 8,500 revolutions per minute. Numbers only tell part of the story. The real advantage was that the M196 reached its numbers with the same crisp response on lap 5 and lap 60, because mixture distribution stayed even and the valve gear refused to go soft when drivers lived high in the rev range. Cooling strategy completed the picture. Radiators were arranged to minimize pressure losses and to feed the oil circuit with clean, predictable airflow. Scavenge stages were sized to keep the sump under control even when the car slid for long seconds at high yaw. Twin-plug indexing matched each chamber's shape, so flame fronts met cleanly. Gear-driven camshafts traded a touch of mechanical noise for timing fidelity, a virtue when the valve train answered to two profiles. The Straight-8's length, usually a liability, became a virtue in the Streamliner because it let the body taper smoothly without the swollen cross-sections that mid-engine layouts would demand years later. Direct injection and desmodromics. Precision over guesswork. Two choices erased the mid-century weaknesses that defeated rivals. First, Mercedes partnered with Bosch on mechanical direct fuel injection, adapting aviation practice to racing petrol. High-pressure pumps metered fuel directly into each cylinder, indifferent to fuel slosh that starved carburetors through long high-G sweepers. The payoffs were cumulative. Cylinder-to-cylinder distribution tightened, throttle response sharpened, and fueling targets stayed repeatable as temperatures and loads changed. Period notes describe an aggressive brew: benzene, methanol, high-octane petrol, small amounts of acetone, even nitrobenzene, followed by a gasoline flush after events to prevent corrosion. Second, the cylinder head used desmodromic valve control. A second cam profile and follower positively closed each valve, replacing spring reliance with mechanical authority. Valve float, the silent assassin of racing engines at high RPM, was pushed off the table. With valve motion secured, the cam could be aggressive without the usual penalty, and the engine's breathing curve stayed honest where others faded. The combination of injection and desmo did not add spectacle, it removed uncertainty. Mercedes could plan races around sustained pace instead of nursing hardware and hoping springs held together. The injection hardware itself rewarded discipline. Each cylinder saw a dedicated line and nozzle so calibration could be written per hole if necessary. Drivers learned to trust the first inch of throttle travel, a rarity in an era when carbureted engines could stumble after long corners. Desmodromics demanded careful metallurgy and finish on followers and rockers, yet paid back in survivability when lift and acceleration numbers grew bolder. The reward was not maximum RPM for its own sake, but the freedom to hold a gear longer without flirting with float, which reduced shifts and kept the engine settled at exits. Taken together, the two systems compressed the list of ways a race could go wrong. 2 bodies, 2 displacements, 1 philosophy. Because the car and engine were drawn as one, the platform could be tailored to wildly different missions without betraying its logic. The enveloped Monza streamliner hid the wheels under a fair, clean shell and exploited the low, slanted engine to carve a needle nose. It thrived on fast circuits, where exits fed long straights and efficiency paid lap-time dividends. The open-wheel car traded a small drag penalty for visibility and precision. Drivers could read tire shoulders and place the front axle on the exact line they wanted. Under both skins lived the same supporting cast: a 5-speed rear transaxle that kept ratio steps tight, inboard drum brakes that trimmed unsprung mass and heat at the hubs, and torsion bars with geometry aimed at a very low roll center. Wheelbase options let the team choose stability or rotation as the venue demanded. Parallel to the Grand Prix unit stood a close relative: the 3.0-liter M196S for the 300 SLR sports racer. It adopted square 78.0 by 78.0 millimeters dimensions, lower compression around 9:1 for standardized 98 RON petrol, and calibration for relentless endurance work. Crank torsion strategy and firing order diverged from the F1 engine to suit hours-long stresses, yet the family resemblance, direct injection, desmo, crossflow head, dry sump, remained unmistakable. The SLR variant added a celebrated party piece that revealed the same mindset: a driver-operated air brake hinged from the tail to bleed speed at the end of straights without boiling the drums. That device was born from the same equation that created the canted engine and needle nose: aerodynamics doing work so mechanical systems could stay inside their comfort zones. In practice, it reduced fade, kept tire temperatures in range, and let the car carry short-stint aggression into the second hour. Grand Prix regulations forbade such devices, but the lesson migrated back in the form of better ducting and stricter thermal budgets. 1954. Proof by results. Proof arrived immediately. On 4 July 1954 at Reims, the streamliners locked out the front and finished 1-2. Juan Manuel Fangio leading Carl Kling in a display that looked inevitable, even though it was the program's first day back. For the German Grand Prix at the Nürburgring, Mercedes arrived with the open car. Fangio won again, and the case for dual body styles became a matter of record. He added Switzerland and Italy to secure the title, having rejoined Mercedes mid-season after opening the calendar in a Maserati. Those headlines told the public what the internal documents already said. The package was not just quick, it was repeatable. engineers refined intake tract lengths, experimented with diffuser shapes inside the exhaust, tidied calibration across ambient ranges. The stopwatch saw gains, but drivers felt something more valuable. The car behaved the same in the last third of a race as it had in the first. No mysterious flat spots arrived with heat. No valve train fuzziness crept in when the rev needle lived near the top for lap after lap. That reliability of behavior, distinct from mere finishing reliability, tilted the psychological balance. By autumn, rivals had learned a bleak lesson. The W196 did not need a perfect day to win. It needed a normal day. The supporting metrics told the same story. Poles and fastest laps arrived in clusters rather than as isolated spikes. Pit work grew methodical because less firefighting was required, and the team could script race pace to sit just under the car's thermal ceiling instead of oscillating between bursts and cool-down laps. On circuits that punished brakes and gearboxes, the W196's inboard layout and 5-speed spread blunted attrition. On venues that rewarded aero cleanliness, the Streamliner's tiny frontal area simply cut work from the engine's to-do list. 1955. Peak form, dark horizon. The following season tightened every loop. Sterling Moss joined Fangio, mass trimmed further, and packaging became neater still. Final 1955, development pushed the M196R toward 290 brake horsepower at about 8,500 revolutions per minute, while the team won 5 of 6 championship rounds it entered. Moss claimed a landmark home victory at Aintree. Fangio ruled the rest with the same unhurried brutality that defined the car's demeanor. The sports car sister, the 300 SLR, translated that form into endurance, proof that the underlying design was a system rather than a one-lap gimmick. Then the calendar turned to 11. June in Le Mans. Pierre Levegue's 300 SLR struck another car at extreme speed along the pit straight, launched, and disintegrated into the grandstand. The driver and more than 80 spectators died. Hundreds were injured. Race control kept the event running to prevent blocked exits and panic, while Mercedes withdrew the remaining car. At season's end, the company left major motorsport altogether. Though the Formula One W196 was not the machine involved, public memory merged identities. Mercedes had built the fastest, most uncompromising racing cars of the day, and now those cars were linked to catastrophe. From that moment, the word deadly acquired a second, irrevocable meaning, one the stopwatch could neither explain nor erase. The aftermath forced hard questions across the sport. How should crowds be protected? What constitutes acceptable risk? When does speed outpace the structures around it? Mercedes's answer was to step away. From a performance perspective, the departure looked like a champion quitting mid-stride. From a corporate perspective, it looked like responsibility. Why it beat rivals and what endured. Set the M196 next to its contemporaries, and the edges light up. Maserati's 250F and Ferrari's 625/555 families were paragons of elegant orthodoxy. Weber-fed engines, valve springs, 4-speed gearboxes, and balanced chassis. They were sweet to drive, and, in peak trim, could graze 6270 horsepower. But carburetors do not like sustained lateral load, bowls, froth, and mixture skews. Springs cannot always close valves at the exact moment demanded when RPM climbs past their comfort. 4 ratios drop revs too far between gears. None of those traits doom a car alone. Together, they nibble away at race-distance pace. Mercedes attacked the problem from the other side. Direct injection made distribution a solved variable. Desmodromics turned valve float into a non-issue, letting the cam be written for what the cycle wanted, rather than what a spring could tolerate. A 5-speed rear transaxle meant the engine lived where it made its best work. Inboard drums and careful geometry tamed unsprung mass and weight transfer. The canted installation bought the aero gains that made the Streamliner's nose possible, and the open car then burned those gains into precise placement on the technical tracks. The sum was an operating envelope that degraded slowly with heat, fuel burn-off, and time, precisely the enemy of rivals chasing peaks. Pieces of that envelope still live today. Modern direct injection is electronic and far more nuanced, but its purpose, meter fuel at the point of use with exact timing, matches the lesson of 1954. Desmodromics remains rare in cars, yet thrives in racing motorcycles, where timing authority at high RPM pays lap time. Dry sump lubrication is standard for serious race engines. Rear transaxles remain because they put mass where tires can use it. Value in the marketplace hints at culture too. Grand Prix W196 have set auction records, and the related 300 SLR Uhlenhaut Coupe has been cited as the most valuable automobile ever sold. Those figures are trivia compared with the real inheritance, a blueprint for reading a rule set, removing failure modes in advance, and building a machine whose parts add to each other instead of fighting for survival. Drivers notice the difference in how the Mercedes did its work. Where rivals asked for finesse to avoid stumbling over their own limits, the W196 asked for clarity. Pick a line, pick a rhythm, and it would deliver the same response every lap. That encouraged strategic aggression. Underfuel slightly to save mass because the injection's accuracy protected consumption margins. Choose ratios for mid-corner RPM rather than exit torque because the 5-speed spread could keep the crank on song through an entire sequence. Engineers, for their part, learned to treat the car as a network. Solve an airflow problem and temperatures fell. Fixed temperatures and ignition tolerated more advance. Advanced timing and the cam could be profiled for a wider plateau. Final reckoning. Clarity over chaos. Strip the myth away, and the M196 reads like a manifesto cast in aluminum and steel. Fuel should be delivered by intention, not by atmospheric hope. Valves should be closed by design authority, not by what a coil spring can survive. Mass and airflow should be arranged to erase drag and keep responses crisp everywhere, not just at one point on a dyno curve. Everything else, the streamliner for power tracks, the open car for technical ones, the 5-speed transaxle, twin plug redundancy, torsion bar springing, exists to serve those convictions. That is why the car won immediately. That is why its achievements still feel modern. And that is why the phrase deadly M196 refuses to fade. On one axis, it meant clinical, unstoppable pace, and on another, it became a memorial word tied to a night no one in racing can forget. The program did not end because the stopwatch caught it. It ended because a company decided that victory without public consent is defeat by another name. What remains is the pattern other champions quietly follow. Align rule comprehension with manufacturing discipline. Remove the weak links before they appear. Make the engine, the chassis, and the body speak the same language. Do those things and the stopwatch has nowhere left to hide. In a sport that often mistakes novelty for progress, the M196's deeper lesson is restraint. It did not chase every possible idea. It chose a few that answered the rule set and executed them until they behaved like instincts. That discipline turned numbers into outcomes and risks into margins. Look closely at any championship car since, and you can trace the lineage. Compact packaging that buys aero freedom, fuel systems that think rather than react, valve gear that holds timing where the combustion really wants it. Call it ruthless, if you like. The kinder word is clarity, a design that knew exactly why it existed and refused to do anything else. And here is the last uncomfortable truth the stopwatch never shows. Greatness is mostly subtraction. Remove noise from the signal, friction from the motion, superstition from the workshop, and what remains is pace that feels inevitable. The M196 didn't scream its genius. It whispered it through stable temperatures, tidy margins, and choices that aged well. Imagine it confronting a modern weekend. Data lakes, parc fermé, tires on a knife's edge. Its core would still translate. Clarity before complexity, purpose before ornament. If that sounds austere, good. Champions are built that way. The rest is commentary, drifting as the checkered flag falls.